Alright, welcome back. In this video, we're going to go over constitutional isomers. Okay, on this channel, I've been making videos for a year now. And if you've been watching, if you've been a long-time subscriber or a long-time viewer, you'll know that I'm very honest. And what I'm about to say, don't take it the wrong way. But constitutional isomers is kind of a useless topic. Now don't click off, right? Don't go to organic chemistry tutor now. But when I mean useless talk, I don't mean don't learn it. You should really much learn this. But when I mean useless is because if you go to a university, usually you take 3 different OChem classes, right? There's a huge OChem book, but it's divided into 3 different classes, or if you go to community college, it's 2 semesters. Now, when I took organic chemistry, we only cared about constitutional isomers in the very first class of organic chemistry, like in the first section, like the first quarter or first semester, and then you never talk about it again. Now, it is very common to be asked on the MCATs. If you're going to take the MCAT, you definitely should know it because they love to ask questions on the constitutional isomers. Now, why are you learning this even though it's useless? There are 2 big reasons. One is you need to understand how molecules can have the same amount of carbon, same amount of hydrogen, same amount of oxygen, same amount of nitrogens, whatever, but be connected differently. Second, what this is doing is preparing you for the hard stuff that is to come. Organic chemistry is a big game. Okay, it's a puzzle. That's what it is. Every single organic chemistry problem there is a puzzle. If you like puzzles, you're going to be great at organic chemistry. If you hate puzzles, well, I suggest you start liking them. But what I'm trying to say here is it's trying to prepare you for the harder stuff. If you pretend you don't do puzzles, and someone gives you a 5,000 piece puzzle, you're going to struggle. There's a good chance you're going to struggle. But what you should do is start off with the easier ones, like a 200 piece puzzle, then move your way to a 500 piece puzzle, and a 1,000 piece puzzle, and you work your way up. The better, more practice, the better. That's what this is basically doing, okay? Now, what is an isomer? An isomer is basically an umbrella term. There are 2 different main types of isomers. There are constitutional isomers and stereoisomers. Now, an isomer is basically you have 2 molecules side by side, and then what it is that they have the same amount of carbons, same amount of hydrogen, same amount of everything. They are just connected differently. Those are constitutional isomers. Stereoisomers, which we'll learn later, is the same molecule, same carbon, same hydrogen, same everything, right? They have the same connectivity, but they looked different in 3D space. And I know that's very complicated and, doesn't make any sense to you probably. It will when we get to it. But here we're focusing on constitutional isomers, the first main category of isomers. Now, like I said, constitutional isomers are 2 compounds with the same amount of atoms, same type of atoms, but they are connected differently on a molecule. Let's look at the example here that I have. Butane and isobutane. They both have 4 carbon atoms and 10 hydrogens. If you don't believe me, let's draw them out here. So 1, 2, 3, 4 carbons, right? But then the hydrogens, let's do blue here. 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 6, 7, 8, 9, 10. That's 10 hydrogens. Isobutane, 1, 2, 3, 1, 2, 3, 1, 2, 3, that's 9, and here's 10. 10 hydrogens. Both have 4 carbons, both have 10 hydrogens. So if you were to write the formula here, C4H10, C4H10. Same formula, but drawn differently. Okay? So that is what constitutional isomers are. So let's do some practice problems. Are the following compounds constitutional isomers or the same compound, just a different representation? Now, you can try this on your own, but I'm going to tell you something. Only one of these, either A, B, C, or D, are constitutional isomers. I'm not going to tell you which one, but only one of them are. There's a reason I did this, and I'll tell you, at the end. Now, if you want to try this on your own, let me give you a few hints. The way you do this is you need to name the molecule first. So name both of the compounds. If they are the same name, they are not constitutional isomers. If they have different names, they are constitutional isomers. So let's do A. Okay. The first thing to do is identify the parent chain. It looks like this. 1, 2, 3, 4, 5. Okay. As a little review, why did I not number it this way? 1, 2, 3, 4, 5. If you don't know, please watch my last video. But the reason is because we want the side chains that are attached to the parent chain to be on the lowest number carbon possible. So on this arrangement, we would have a methyl group on 3 and a methyl group of 4. That's pretty high. But if you were to do it the other way and number it starting here, 1, 2, 3, 4, 5, well then we have a methyl group on 2 and a methyl group on 3. That is lower than the other representation. So this would be the correct way. Now let's do the other one. It would be 1, 2, 3, 4, 5. Okay, now let's identify the side chains. So we have a methyl group on 2 and a methyl group on 3. On this one, we have a methyl group on 3 and a methyl group on 2. So, if we were to actually name this molecule, it would be 2,3-dimethyl pentane. So, we have let's break it down. We have a methyl group on 2 and a methyl group on 3. Since we have two methyl groups, we can call it the dimethyl. Di meaning 2 and methyl meaning the methyl group. And we're saying it's on carbon 2 and carbon 3. We separate numbers with commas, but we separate numbers and letters with a hyphen here. So if you have a letter and then say like a letter here and then a number, it would be a hyphen here, no matter what, no matter if the numbers first or the letters first. Numbers and letters are separated by hyphens, numbers and numbers are separated by commas. This molecule, we have a methyl group on 2 and a methyl group on 3, and this is a pentane, 5 carbon long, 5 carbon parent chain. So it is actually the same molecule, same name, same molecule. I mean, sorry, it's the same, like this, the arrangement, right? Even though the arrangement looks different, it's still the same. The name is still the same. This molecule and this molecule are both 2,3-dimethyl pentane. So these are not constitutional isomers. These are just different representations of the same molecule. Let's do B. 1, 2, 3, 4, 5. Does that look right? Yeah, that's right. Okay. And then 1, 2, 3, 4, 5. Okay. So this is a pentane because we have 5 carbon parent chain. Let's identify the side chains. We have a methyl group on 2 and a methyl group on 4, so it looks like we have a dimethyl 2,4. We have an ethyl group on 3. Let's look at the right molecule. We have a methyl group on 2, an ethyl group on 3, and a methyl group on 4. It's looking like it's the same molecule. So this would be 3-ethyl. Now, 2,4-dimethyl pentane. One sec. Okay, why did I write it as 3? Why did I write 3 before 2? Because alphabetically, we name the side chains alphabetically. Ethyl, E comes before M in the alphabet. So we assign the ethyl first. We name the ethyl first because alphabetically E is before M. So 3-ethyl 2,4-dimethyl pentane. These are the same exact compounds, basically, just different representations. These are not constitutional isomers. Let's look at C. I know this one looks wild, but trust me, it's fine. Okay. Let me think here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. You can either put 9 here or put 9 here. It does not matter. Does that look right? Yeah, that's right. Okay. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We have a methyl group on 2, a methyl group on 8. We have, what is this now? What is this? This looks funky, right? Well, count how many carbons. 1, 2, 3, 4. This is a butyl group A butyl means 4 carbons, but notice it branches. Branches like this. If this tree-looking thing has 2 branches, this is an isobutyl group. Okay? So let's name this. And since it's 9 carbons long, this is a non-name. So this would be 4 isobutyl 2,8-dimethyl nonane. Okay? Now, let's look at this one. We have a methyl group on 2, a methyl group on 8. And we have the same isobutyl on 4. This is the same molecule. Different representation. This is not a constitutional isomer. So by process of elimination, right, this is the constitutional isomer. But let's do it anyways. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, this is a 7-carbon chain, so this is a heptane. What side chains do we have here? Okay, so we have a methyl group on 3, a propyl group on 4, because a propyl group is 1, 2, 3 carbons. So let's name this. This would be a 3-methyl 4-propyl heptane. Sweet. Okay, let's look at this one out. This one, we have a methyl group on 2, so we already see the difference here. A methyl group on 2 compared to a methyl group on 3. Okay. So then we have a propyl group here on carbon number 4, so that stays the same. So this would be 2-methyl. Did my thing get thicker? Hold on. I think it did. Okay. 2. That sounds wrong out of context. Okay. 2-methyl 4-propyl heptane. Okay. Sorry. So this is a constitutional isomer because look, we have a methyl group on 3, but here we have a methyl group on 2. Different names, same molecule, same amount of carbon, same amount of hydrogens, everything's the same. That's a different name, as you can see, right? The methyl group is on a different carbon. These are constitutional isomers. Okay? There we go. So, why did I do this, right? Why did I make 3 of them not constitutional isomers and 1 of them constitutional isomers? Because professors like to trick you. On exams, you're probably going to be given 2 similar-looking molecules, right? Or maybe a little different looking molecules. And you're going to be asked, are they constitutional isomers or not? Don't fall for the tricks, right? I purposely put the first 3 as not because I was just making sure, right, you would know, I clearly identify what is the same molecule, same name, and what is a different name. If you found this video helpful, please like and subscribe. Or if you found this video funny, like and subscribe. And until next time, later.